Hi, this is Sabin Pathak. I am the thesis student of the stream Master of Science, Energy and Environmental Technology in USN at Campus Proscon. Today I am going to present about a short background of my thesis topic, objective and some of the achievement. My thesis topic was study on the startup of anammox process in lab scale moving bed biofilm reactor. This research project was organized by USN in collaboration with Biowater Technology. Anammox is a widely used biological method to treat the ammonium present in wastewater. In anammox process, ammonium present in wastewater is oxidized into nitrogen gas with consumption of nitrite in anoxic environment by anammox bacteria. Since the wastewater have low content of nitrite, preceding partial nitration process is also required to provide sufficient substrate for the anammox bacteria. In partial nitration process, half of the ammonium is oxidized into nitrite by AOB in aerobic environment. Why ammonium should be removed from the wastewater? This is because excess in ammonium concentration cause eutrophication, and also the high concentration of nitrate have negative health effect on infants and pregnant women. Ammonium can be removed by different processes such as physical, chemical and biological processes. Among these alternatives, biological process is efficient and cost-effective technique. Again, in biological process, there are convection nitrification, denitrification process, one-stage PNA, two-stage PNA. Among different biological alternatives, one-stage PNA is the best. In comparison with the traditional process, one-stage PNA have 63% less aeration requirement because only half of the ammonium is required to convert to nitrite and no need of nitrate production. Also, the PNA process is a complete autotrophic process, so no need of BOD and COD for denitrification, and also the sludge yield is lower by 80% in comparison with traditional nitrification denitrification process. In comparison with two-stage PNA, it required less space and also the volumetric removal rate is higher. Therefore, our main objective is to develop the anammox condition in lab reactor using synthetic wastewater and without using any specific anammox sludge. To achieve the objective, CSTR MBBI reactor was set up in the USN laboratory. In the reactor, 5 liters of carrier were used. Among them, 3 liters of carrier were used from Kanarastan wastewater treatment plant of Proscon to provide the sufficient nitration biofilm. The reactor was operated daily to measure DO, pH and temperature, while laboratory analysis of nitrogen compound were done in 1-day gap. To achieve the objective, the reactor was first operated with 2 different SLR under continuous aeration. Despite the DO by 10 was low enough to suppress the NOB and the free ammonia was higher than inhibition range of NOB, NPR was always higher than NAR. This means the high active of NOB. This result was due to the either growth of a nitrospira or the limited thickness of biofilm. However, to confirm this, detailed microbial analysis should be carried out. Then the aeration strategy was changed to intermittent aeration and to different intermittent aeration cycle was applied, ISC2 and ISC4. The closed partial nitration was observed when ISC2 was stabilized at ISC3. The value of NAR was higher than 70% and NPR was less than 30%. Since still there was some NOB after imposition of ISC2, another intermittent aeration cycle ISC4 was applied, which resulted in slight decrement of NPR and ARE, but NAR was same. This means more suppression of NOB. The composition of bacteria were measured by OUR. In both the composition of heterotroph, AOB and NOB were in descending order. From figure, we can see that AOB were in slight increasing trend and NOB were very weak decreasing trend, which signify that the remaining removing of biomass after it has been attached to the carrier is hard and time consuming. Since the whole time in the thesis was utilized for NOB suppression, this resulted in unsuccessful startup of anammox process. However, based upon the literatures, the decrement in aerated length in intermittent aeration cycle can achieve more suppression of NOB for partial nitration. After achievement of complete partial nitration, sludge from either anaerobic digester or from denitrifying basin should be used for the fast startup of anammox process. Thank you.